For today's class, we are going to talk about the aristocrat cipher, patristocrat cipher, and then talk a little bit about K1 and K2 alphabets. And then I might have some time separately set apart for practice problems at the end, but I also might not because we'll be looking at a lot of examples as we go through. So first of all, aristocrat ciphers, it sounds a little bit fancy. It is not that fancy. It's just a regular monoalphabetic substitution cipher where you just substitute, you choose for each letter of the alphabet what other letter of the alphabet you want to substitute it with. And you don't have to follow any particular order with these mappings. So it's almost just completely random, whatever substitution you want, as long as it's distinct. So more specifically, to encrypt with the cipher, you want to first choose your plaintext to ciphertext mapping. So this can be, like I said, it can be anything, like completely random, whatever you want, as long as every letter is distinct. So this means you can't encrypt a letter to itself. Like you can't have A in plaintext be A in ciphertext, and this is mostly for security reasons. And you also can't have duplicate mappings, which means you can't have A and B both mapped to C in ciphertext, and you can't have something like A in plaintext mapped to both B and C in ciphertext. So that's the only restriction on the aristocrat cipher. So for this example here, if you want to use this plaintext ciphertext mapping of whatever the ciphertext is, all you have to do is substitute the letters of the plaintext with its corresponding ciphertext letters. So for example, you see that the first letter of plaintext is a T, so you just go to the table and you locate the corresponding ciphertext letter, which is X. And this is basically what we've been doing this entire time. So it's nothing particularly new, except for the fact that it's mostly random mappings. So now for decryption, once again, as I've said every single class, there are two cases where you have known mappings or you have unknown mappings. So for known mappings, as usual, you just substitute ciphertext letters with plaintext by looking back at this table. And for unknown mappings, it requires a little bit more nuance and technique. So it's not complicated, but it requires some practice to be able to do it efficiently and effectively. So longer ciphertexts tend to be easier to decrypt. Like if you remember on the first day, I think when I was talking about the Vigenère cipher, I also mentioned how longer ciphertexts are easier to decrypt because there's more patterns you can see, frequency analysis becomes more reliable, etc. So with aristocrat ciphers or with aristocrat ciphers, about 2 to 3 sentences should be enough to give you, is usually enough to give you sufficient hints as to how you might approach this problem. So for shorter ones, you can apply similar techniques as with longer ones, but it will almost always require some brute force towards the end to figure it out. So first, when you're trying to decrypt in aristocrat cipher, you want to start by identifying entry points. And by entry points, I just mean points, or not points, but words or letters that you can decide with a fairly high degree of confidence that this decrypts to something. So to identify these entry points, you want to observe frequency, repetition, and length. And we'll talk a little bit more about this in detail in a few more minutes, but briefly, once you identify these entry points, you can decrypt these ciphertext letters, and then you can apply those ciphertext to plaintext mappings to the rest of the ciphertext, and this will help you look for more entry points and so on and so forth until you have decrypted the entire thing. So a few things just as a starter to look out for. You want to look out for single letters, apostrophes, and repeated letters in a word. So both consecutive repeated letters and non-consecutive repeated letters. Okay. And I'm going to mostly explain these techniques for decryption by going over a few, well, I think like many examples, but of course I can't cover every trick or common pattern because that will come with practice. So it's taken me many hours to be able to decrypt aristocrat ciphers quickly. So once again, if you want to do it quickly, you gotta practice and you can't just sit and listen. So because of that, I also invite you to follow along as I explain and see if you can find better ways or other ways to approach these decryptions. So for this cipher right here, if you want to always start off by observing, first of all, the word frequencies, word lengths, and mostly word frequencies, well, sorry, word letter repetitions within a word. So one of the most reliable or one of the most common as well as most reliable patterns you can see in a lot of ciphertexts is this four-letter, if I can annotate right now, you see this four-letter word that starts and ends with the same letter, and you can see that the start and end letter are both have pretty high frequencies. So the ciphertext Q has 13. And by the way, the small numbers underneath the letters just denote how many instances of that ciphertext letter there are in the entire ciphertext. So looking at this four-letter word, I can almost immediately tell you that there are only a few possibilities for it. So the most common possibility would be that, as in THAT, and I know this because, first of all, that is a very common, not very, a very commonly used particle, not particle, it's some type of speech in English, and as well as the fact that because it starts and ends with T, and T is the second most common letter in English, so it makes perfect sense for this ciphertext letter to be common as well. So another possibility for this four-letter word would be else, as in ELSE, but this is not as commonly used as that. So normally your first approach to this word would be that. So if we, yikes. Okay, if we try to match the plaintext word that to this ciphertext QVMQ, we know that Q in ciphertext decrypts to T in plaintext, V decrypts to H, M decrypts to A. So we can then apply all of those decryptions to the rest of the ciphertext, and these boxes on top of the ciphertext in this thing, like these boxes just plaintext, and underneath this is the ciphertext with its frequency, in case that looks a little bit confusing, and just disregard the yellow highlights. So how do I yeah, so once you've filled in these decryptions that you just figured out, you look at it again, obviously, and then you identify the next point where you want to attack the ciphertext from. So a few things you might notice here are okay, are you see this here and you see this here. So these are extremely large giveaways, as well as, well, this one here, but this is a little bit more minor. So if we first look at this up here, so you see the plaintext 2 followed by an unknown plaintext letter. So because English is English, the only possible letter that can follow a T in a two-letter word is an O. So we immediately know that this should be an O. So that's okay, yeah, that should be an O. And then if we apply that to the rest of the ciphertext, we get some more things. Oh, and also note here, I only talked about that and else as possibilities, but of course there are also other possibilities of the first and last letter being the same in a four-letter word, like says or dead, but of course these are less common than that. So once again, that should be your first, well, yeah, the word that should be your first instinct when you see this kind of pattern. Now, oh, okay, 1 second, go back. So another thing you might notice about the ciphertext is this. So the thing with the TH in plaintext followed by another unknown plaintext letter is that if you're dealing with a ciphertext that was for some reason written in Old English, you have two possibilities. It could either be the as in THE, or it could be thigh as in THY, which I know nobody says that anymore, but Old English. So this is sometimes not the best next step to take, because sometimes if you try E, it turns out to be incorrect, and then it gets confusing. But then in this case, you can say with a fairly high degree of confidence that this unknown plaintext letter at the end, the ciphertext letter A, is an E because of its high frequency. It's even more common than the plaintext letter Q, which we know as T. So it's extremely likely that this ciphertext letter A is supposed to decrypt to E. Now, if this A were of slightly lower frequency, say there were only 3 or 4 instances of the ciphertext letter A in the ciphertext, then we might want to first assume that it is supposed to decrypt to Y, because Y is a lot less common. But in this case, the A is extremely common, so we can say with fairly high degree of frequency that it is supposed to be an E. And then if we apply that to the rest of the ciphertext, you see that there are more letters decrypted, obviously. Now, going back to what I said about this chunk here, this 2-letter word starting with T. And so we know that is supposed to be a O because English. And once we fill that in, we see even more letters. Now, once we have this, the thing you will immediately notice once you've practiced a lot is this thing here. So something O, something OT. And this is almost certainly going to be do not. It could be like so got or something like that, but that tends to be much less common than do not, especially when it's like the second and third words in a sentence, because this is English sentence structure. So if we fill in do not in this ciphertext here, then we can get C decrypts to D, D decrypts to N, and then we fill that in the rest of the text, and we see more things. Now, the next approach here is to fill in this 3-letter word here, or it would be better if you looked at it here probably. So here. Now you see it's the first word in a sentence, and it's the first word in a sentence followed by a verb. So usually this is going to be either you know what, I don't know the parts of speech well enough to talk about that, but chances are it's going to be you, because English. So if you fill in U for this ciphertext word, and then, so you know F decrypts to Y and W decrypts to U, you will have more letters revealed throughout the rest of the ciphertext. And then once you get to this point, oh, of course, okay. I have to talk about, so the thing with the ciphertext word being 3 letters long and having the middle letter as O. So here, if it's going to be your subject of the sentence, basically your only 2 possibilities are you or God. So in this case, because we already have the plaintext letter D, the plaintext letter D is already taken, and like I said before, we can't have 2 ciphertext letters mapping to the same plaintext letter, so we know this has to be you and not God. Now, after that, we look at this, okay, we look at this here, which is something followed by an E in plaintext. So as for this 2-letter word, your only possibilities in English are me, we, be, or maybe re in a very special case. But if you look at the sentence itself, so you see you do not something want to something. So Of course, if you try me, we, and re in the sentence, it doesn't make sense. You can't say in English, you do not blank want to me. That is illogical. So of course your most logical option is going to be. So you do not blank want to be something. And this now makes sense. Now, your next step is, so once you get to this step here, you can, or I believe you should be able to just start filling in the words based on word recognition. So you see this here, if you've read some like books, I guess, you will note that this is probably merely or merely, I don't know how to pronounce that. Anyways, you do not merely want to be whatever, whatever, whatever. And then once you fill that in, you also see that this becomes only, and this makes sense. Yay. And once you get to this point, you've pretty much decrypted the entire thing. You just have to fill in the last few letters, such as the considered part. If you look here, basically your only possibility is considered. You might have some more obscure English words that would also fit that block of ciphertext, as in this ciphertext thing, but you want to go with, generally you want to go with your first instinct because that is going to be the most commonly used instance of, or the most common English word that fits in this ciphertext word. So you fill in considered, and then all you are left with is this one blank, and of course that is going to be of, because the only other possibility would be or on, and both of those, the R and the N are already taken. So you do not merely want to be considered the best of the best, you want to be considered the only ones that do what you do. And that is the quote decrypted. So in this quote, you will notice that once we have our just one entry point with the that, we're pretty much, the rest of it pretty much comes naturally, and there's literally no brute force required. So you just go by observation, and you go by, well, critical thinking, I guess. So this is one of the more straightforward cases where you have a clear point of entry and you have a clear process from there. This next one, oh, why did I, okay, anyways. This next one here is also fairly straightforward, but slightly less so. It requires a little bit more experimentation. So, okay. So if you see this ciphertext letter up here, ciphertext word, sorry, you will note these word frequencies at the bottom, which is a 6, 2, and a 7. So from this, you will observe that the 6 to 7, the 6 and the 2, or the Y, the ciphertext Y and the ciphertext K, are two of the most common letters, or are literally the two most common letters. Well, okay, two of the most common letters in this ciphertext. So when you see a pattern like this, where you have a 3-letter word with the middle letter being a little less common, and the first and last letters being of similar commonness or of similar frequency, then your first instinct is going to be the, because T and E once again are the two most common letters in English. So, however, in this case, if you try putting the in, okay, if you try putting the in like this place, you will find that it doesn't really make sense. So your the first giveaway to it not making sense is going to be this, oops, this thing here. So this 2-letter word ending in H. And the reason this doesn't make sense is in English, in usual English or written English, there are no 2-letter words that end in H. Of course, if you're speaking, you have like eh, ah, oh, etc. But this is not very common when you're writing it out. I'm sure you know, you don't write oh, in essays. So this is going to be your first giveaway that something doesn't look right here. Your second giveaway is going to be this 4-letter word here, where the middle 2 letters are double T's. So the reason this doesn't really this isn't going to really look right is because English doesn't normally have two consonant words, two consonant letters repeated in the middle of a 4-letter word. So with 4-letter words, so I'm only talking about 4-letter words here and not about like longer words because that's a different case. So with 4-letter words, in 99.99% of cases, your middle 2 repeated letters, if they're repeated, are going to be a vowel, and this vowel can only be an E or an O. So from this, you might go back to the, well, I guess, the plain text the you just attempted to decrypt, and you'll find, well, you won't find, but you'll try to maybe adjust it somewhat. So with the final letter E, you see not many problems visibly. So you're going to want to first try changing T and H to something else. And fortunately, in English, there are a lot of other, not a lot, but there are a few other common 3-letter words that end in E. So because of what I said earlier about the middle 2 repeated letters being either E or O, you might want to try this letter here actually decrypting to an O instead. So if you have a 3-letter word, the first letter is O, the last letter is E, you have maybe 3 possibilities. So it's either going to be one O as in OWE, or maybe in some cases you will have OL as in OLE if you're being old-fashioned like that. But for now, we're going to go with 1 because this is the most common possibility. So you can see the case, if we try 1 here, you'll notice that this immediately looks a lot more logical. So you have this double letter O here, and this ends with N instead, and there are going to be actual possibilities for English words that end with N. So this is going to work, basically. And once you have that, you might also notice that you have a very similar 3-letter word pattern here. So once again, it's very similar to this part where we just decrypted to 1, but the first letter is a little less common, and the middle letter is the least common of all 3 letters, and the last letter is E. So you might go back to what you were thinking earlier with the, and you might try to put the in here. So B decrypts to T and F decrypts to H. You know what, I can just go to the next slide. Okay. Oops. Okay. And then you find that this doesn't look incorrect. And usually if it doesn't look incorrect yet, you can keep going until it does look incorrect. Or if it doesn't ever end up looking incorrect, then you just go until you solve it, of course. Now, once you decrypt this part to the, you can apply those decryptions to the rest of your text. And then once you do that, I think the first thing you might notice is this up here, actually, is it? Oops, ignore that. Okay. First thing you might notice would be this thing up here, where I think I'm okay. So it starts with E and it ends with H, and it's a 4-letter word. So in this case, you don't have a lot of possibilities, even though it looks like you're missing 2 letters. Well, you are missing 2 letters. So you're missing 2 letters, so it might look like you have a lot of possibilities, but you really don't, because in English, in most cases, if you have a 4-letter word starting with E and ending with H, that's going to be each, as in EACH. So if we fill that in, so P decrypts to A, E decrypts to C, etc., you'll get a lot more like ciphertext to plain text letters filled in. And then I'm not going to keep going with this one because after that it just becomes extremely self-explanatory, and that's all I need to talk about for this one anyway. So the next case, I believe this is a completely different ciphertext, as you can see. So the first thing you'll notice is this here. So you have a letter and then an apostrophe and then another letter, and pretty much, I guess you can call it the same word. So in this case, you basically only have two possibilities for what this word might be in plain text. It's either going to be I'm or I'd. So either I apostrophe M or I apostrophe D, as in contractions for I am or I had. So most of the time, it's going to be I apostrophe M. But of course, if that doesn't work, you can always go back and try the other possibility of I apostrophe D. So here we first go with I apostrophe M because once again, most common possibility. So you fill in those decryptions through the rest of the text, etc. And then your next approach is going to be looking at this thing here, which I can't see. This thing here. There's someone screaming outside. Okay, anyways. Right, so you have an M followed by some other plaintext letter, and you can see from the small number right underneath the ciphertext letter that this plaintext letter, well, or the ciphertext letter, it's kind of the same thing, is extremely common with 17 instances. So your first thought is going to be E, and you would be correct if that was your first thought, which is good. Now, but once you move past the first thought, you might think of other possibilities. And actually, the only other possibility is going to be my, as in my. Well, you have a small chance of it turning out to be like ma or something like that, but that's weird. Now, in this case, we can say with pretty high confidence that the S is going to decrypt to E because of how common that letter is. Now, if it were less common, like say if the ciphertext S only had 3 or 4 instances, you might want to go with my, but actually in this case, this wouldn't make that much sense either because this 2-letter word comes at the end of the sentence, and in no case will you ever put my at the end of your sentence in English. So at least if you're being grammatically correct, which in most cases, ciphertext will be actually grammatically correct. So if you fill in E, you will, see things, obviously. You will have a lot of decryptions. Now, your next step or your next entry point is going to be if you see this here as well as this here. So two things you'll notice is once again with this 3-letter word down here, you have the pattern of the, with the first letter being common, the second letter being less common, and the last letter being H. Sorry, not H, E. And with this 5-letter word up here where you have an E in the 3rd and 5th positions, you will almost always find that this is going to be either there, as in THERE, these, or where. So in this case, because we can see that the ciphertext letters here are J and N, and the ciphertext letters here are J and N, this is going to be, as in they're the same ciphertext letters, this is going to have to be TH because otherwise it doesn't English. So you can apply that to the rest of the text, and then you have this. And then once you're here, you start noticing, hopefully, a lot of words that you recognize, at least vaguely. So okay, so some things you, oops. Okay, some things you might notice would be, why did I do that? Help. Okay. This thing here, the 2-letter word following the something, and then this 2-letter word beginning with I. So because of, once again, English, this is probably going to be is, as in IS. So your other possibilities, as in like your other possibilities for 2-letter words starting with I would be if, or if, in, or it. Now we know first of all that it can't be it because T, the plaintext letter T is already taken, and if doesn't make sense because it doesn't grammatically fit into the sentence, and in also doesn't really make sense for that same reason. So we go with, if we go with is, and we go with is, we have this here, and then once you get to this point, this is kind of like the critical point where you can almost just look at the words and straight up just write out what they are from word recognition. So so in this case, because yikes, help, okay. How do I, okay. So in this case, if you don't want to just like straight up go from the beginning and try to recognize words, so if you don't have like as much word recognizing yet, you might notice this thing here that I can't circle because it's in the way. Okay. So this thing here, and you'll notice that the first letter and the second to last letter are the same, and the middle letters are THI. So this is going to seem like a bit of a stretch or a bit of like, or a bit difficult to recognize at first. But once you get used to decrypting aristocrats, you'll find that you'll recognize these patterns very naturally. So in a case like this where you have a seven letter word with the first and sixth letters being the same and the middle three letters being THI, you will know that this is going to be nothing, as in the word nothing. So once again, this is going to seem a little bit of a far extrapolation to make from just three letters and some repetition, but once you get used to it, it will come naturally to you. So for now, I'm just letting you know. And once you know that this decrypts to the word nothing, you can of course apply those decryptions to the rest of your ciphertext. And then after that, you will find that you have, of course, you see this pattern again. And of course, you could have recognized that earlier, but it doesn't make too much of a difference with this one because usually approaching it from this entry point and that entry point aren't going to make too much of a difference if your entry points are both fairly solid and they both deal with if they're both fairly reasonable, I guess. So of course you recognize that this is going to be that, and there is no other possibility unless you want to go into slang words, but we're not doing that because this is not about slang. So you decrypt the ciphertext C to a plaintext A, and then you can basically just fill in all of these words now. You'll recognize that this just says, I'm certainly not into money and prestige, because the thing with recognizing words is that if you just try to read off the fragment that you have, your mind will kind of autofill the rest of the word for you, because you're so used to reading that specific English word that just seeing a fragment of it will help you know like what the rest of it should be. So in this case, the quote is just, I'm certainly not into, actually it doesn't matter what the quote is, but yeah, word recognition, and you can pretty much just fill in the entire rest. This is the end quote decrypted. Now, another example, this is another case of where you have apostrophes, but it's not quite the same as the last one. So the previous one, we had a two-letter word with an apostrophe between the two letters. This case, we have a three-letter word with two letters and then apostrophe and then one letter. So if you English a lot, I guess, you'll know that your only few possibilities for a word like this is going to be, well, a word like, let's see if I can circle it, a word like that is going to be it's, it, I can't pronounce that, it apostrophe D, it apostrophe S, or he's or he'd, or maybe weed, as in not weed, but like we apostrophe D. So like I wrote here in this arrow, I think you can see that, right? So once you fill in that, and in this case, when you see like this three-letter word with an apostrophe between the second and the third letter, as usual, you're going to have a first instinct, and that is almost always going to be it, because that is probably the most common out of all of your possibilities here. So once you fill in that, you will once again notice this this kind of thing here that I can't circle because, okay, that. You notice this thing here. So you have two three-letter words in a row, and oh, you have two 3-letter words in a row, and the first one ends with T, the second one starts with T. So if you just look at these 2-letter words individually, if you just look at the second one, for example, you notice that this looks awfully a lot like the, except maybe not quite like the usual the pattern you're used to seeing, because the middle letter isn't quite as uncommon. So of course, if you just fill in the for that letter here, for that word here, you'll find that it does actually work. But my point here is that if you look at these two 3-letter words as a block, and you take into account the context of the sentence, which is that the sentence begins with it's something something something. So because because these two 3-letter words follow the it's, because of English, you're almost always going to have like not the, as in the words not the. So you can see here that actually works out perfectly well. And this is just a English thing. Like you, of course, you have other possibilities, like it's got the, or it's something to that effect. Like you can think of other possibilities, of course, but most commonly, and the thing with like solving aristocrats in general, is you're going to be thinking about what's most common. So most commonly it's going to be not the, and in this case it is indeed not the, and then you can just fill in that, the not the part, and its corresponding decryptions. And then the next thing you'll notice here is you have O followed by a blank. So I think I mentioned this briefly before, but now just to be a little bit more specific, when you have a 2-letter word of O followed by something, your only possibilities are on or of. And of course, in this case, on doesn't even work because the N is already taken, or just doesn't make sense grammatically. So you're going to have of, and this does make sense. And once you have this down, you can pretty much just decrypt the rest of the quote. Actually, in this case, you might need to do a little bit of brute forcing because you do have some less common letters that have multiple possibilities. Like for here, you might think it could be size or it could be side. And with that, you just want to try them out and see that which one makes more sense in the context of the rest of the sentence. Now, another thing you might notice, or actually maybe you don't notice, but that's fine. So is this thing here. So unlike where you had not the here, this is also a 3-letter word that ends with T followed by a the. But the thing with this here is that because you see these first two ciphertext letters are extremely uncommon, if you see something like this, especially if it's following a comma in the sentence, chances are your word here is going to be but the, as in B-U-T. So yeah, and that's just because of English word patterns are like that. Now, that's going to be all for this ciphertext, and here's another example where, let's say hypothetically for this ciphertext, actually we're not finished with this ciphertext yet. So let's say hypothetically, when we're approaching this 3-letter word with an apostrophe in the middle. So let's say when we first approached that word, we just decided to try he's as an H-E apostrophe S instead of its. So if we do that, we will find that it stops making sense, because once we fill in the HES decryptions for the rest of the ciphertext, it just doesn't look like a regular English sentence anymore. And of course, there are cases where your ciphertext is going to be weird or like uncommon, but usually, well, that's called uncommon for a reason. It's not common. So in this case, if you try putting he's in the first spot, then this will turn out to be, well, one of two possibilities. You can either have end or you can have something like eat. And ignore the fact that this looks kind of like profanity, but none of these actually make sense, especially here. Like, okay, first of all, if you want to look at this example, this isn't a common, well, you could have an English word like that, but it's not common. And in this case, your giveaway that this is incorrect is going to be this 5-letter word that ends in AE. And there are literally no common 5-letter words that end in AE because this is not a pattern that exists in English. So, yes. Now, for another quote here, this is another apostrophe case because there are multiple types of apostrophes in English, as I hope you know. So what you might notice here is, oh geez, okay. What you might notice here is that you have a fairly long, you have a long string of letters, a comparatively long string of letters, followed by a apostrophe and then followed by something. So in this case, you have basically two possibilities with this 6-letter string followed by apostrophe followed by a final letter. So it's either going to be wouldn't or couldn't. And if you had a slightly longer string, so if this string preceding the apostrophe were to be 7 letters long, then it might be shouldn't, but because it's not 7 letters long, it's only 6 letters long, it's only going to be couldn't or wouldn't. So because we don't know if this is a C or a W, the first letter, we're going to ignore the first letter for now, or we're just not going to decrypt it for now and just fill in the rest of it. So when we fill in the rest of it, we find you see words. Of course you see words, but like, okay. You'll notice this singular letter here preceding the either wouldn't or couldn't, whatever that word is. So because of English, once again, the only 3-letter words, actual words that exist in English are I or A, and maybe in some cases, like Old English, O. But in this case, you will find that it has to be I, because ignore that for now. You find that it has to be I because as a subject for the sentence, you can't have A. Like, you can't say A wouldn't do something or A couldn't, whatever. You can only say I couldn't or I wouldn't. And you definitely can't say O. So there's that. And also, something that might help here if you're trying to figure out if this word here is wouldn't or couldn't is if you just like try them out. So if you try putting a C there, you find that this just doesn't work because C blank NT, if you ignore profanity, is not an English word or not common. So, it's not going to be couldn't. Your only other possibility is wouldn't, so it is wouldn't. And in this case, this makes sense because you can have wouldn't want to, blah, blah, blah. Now, going back to what I said about the singular letter, it is I because English. And once you get here, you can just see, like, for example, this is going to be the because you have a fairly common last letter, uncommon middle letter, and T at the beginning, and etc. Once you find that, you can pretty much just go through the whole thing and it decrypts very cleanly, I suppose. And you get this final decryption. And you'll also see here that you see this same pattern of there. So a good way to recognize there actually is because it starts with THE, it starts with the. If you see like this, and then you also see this, you know with pretty high certainty that it's going to be the and there. So now for this one, what am I talking about? Okay, so for this one, you might see this apostrophe in the middle here, this apostrophed word in the middle here, and you might want to say it's couldn't or wouldn't. Now, if you try that out, you will find that it doesn't work because that's not actually what the word is supposed to be. Because another possibility for the apostrophe, like apart from what is it called, contraction, is possession. So like something apostrophe s. Now, because we don't know what this apostrophe word is for certain, we're going to not look at that for now. And instead, we're going to look at, oops, you didn't see that. We're going to look at this thing here. And this is going to be a weird thing to like, it might be a little weird to think of looking at this part first, because you might look at it and have no idea what to do with it, and that's pretty normal because this is actually a little bit of a, I guess it's not the most um utile thing to recognize at first sometimes, but once you get used to decrypting aristocrats, you'll find that this is going to be very helpful actually. So you see a 6-letter word, and the middle 2 letters are repeated and the first and fifth letters are repeated. So this seems arbitrary to you, but in reality, in English, there's not a whole lot of possibilities you can have with a pattern like this. So your biggest, uh, I guess, the biggest option or the most common option here is going to be little, because that actually fits with the pattern of the ciphertext. So if you put in little, you'll actually see a lot of things are revealed to you. Like you'll be able to notice this T followed by something here, which you know is an O. You'll be able to see this and know that this definitely can't be couldn't or wouldn't. So you know that this is going to be an S. That's not an S. That's going to be an S, and so on and so forth. So you apply those accordingly, like the O and the S, and then once you get here, you can also notice a singular letter here, and because you've taken the I with a little, the I already maps to something in ciphertext. This singular letter K in ciphertext is going to be A, and so on and so forth. Once you get through that, you can pretty much just automatically decrypt everything. Not automatically, but yeah. Okay, and that is apparently all for a very limited overview of aristocrats, but it is not possible to go over every possible technique or trick. So does anyone have any comments, questions, rants, exclamations? Okay, so in that case, we'll just quickly talk about these patristocrats. So patristocrats is like a aristocrat, but without spaces or punctuation. So it's literally the exact same method of encryption, but you take away all of the spaces, you take away all of the punctuation, so it automatically becomes harder to decrypt because you can't rely on word length at all anymore, because it's just put together into one giant string. So to decrypt patristocrats, if you know the mappings, of course, that's going to be the same old method as usual. You just map the ciphertext back to plaintext because you know how to map them. Now, if you don't know the mappings, some, I guess, rules or techniques from the aristocrats still hold over, but not particularly well. So instead, what you want to focus on with patristocrats is to search for strings that appear more than once, and the longer the better. So this is a little bit like, actually, okay, no, I won't talk about that. But you search for strings appearing more than once, and the longer the better. So the point of it being longer is it's less likely to be a coincidence. So for example, if you find a 2-letter string that appears like many, many times, that could easily be like, that doesn't mean that doesn't mean it's the same word. Or of course, it's going to be the same plaintext letters, but that doesn't mean, like, for example, if you find uh, 2 letters repeated multiple times. In one case, it might be is as a word by itself, and in another case, it might just be part of a larger word like wisdom or this. And so that's not going to be very helpful to you. However, if you have a pretty long word, then it's less likely for it to be just part of another word, and so that'll be easier for you to figure out. And another thing you want to pay attention to is repeated letters. So repeated letters is one of the things from aristocrats that actually continue to help you in patristocrats. So repeated letters is, well, of course, it's not as helpful as in aristocrats because you don't know how long the word is, so you don't know if the letter repetition is part of the same word or not. But even if you don't know if it's part of the same word, it can help you, it can give you some ideas. And um okay, I guess I won't go over the example for now because that takes a little bit longer than we have. So Um, I guess I can do that next class. Anyways, so actually it's something, so I said earlier that aristocrats and patristocrats were completely random mappings of ciphertext to plaintext or plaintext to ciphertext, but some cases you can actually create a more orderly, or I guess, yeah, more orderly way to have these mappings without going completely like Caesar cipher mathematically mapped or whatever. Now, so here we have the K1 and K2 alphabets, and this is just abbreviations for two different types of keyword alphabets. And what a keyword alphabet is just like what you use when you're encrypting a substitution cipher. It tells you what plaintext letter maps to what ciphertext letter, and a keyword alphabet contains a specific word, which is called the keyword, obviously. And then you have the keyword in either the plaintext or the ciphertext, and then the alphabet just proceeds regularly from there without repetition. And if that seems a little bit like uh, confusing right now, I'll explain in depth in just a second. And well, of course, okay. So when I say containing a specific word, I mean like containing the word, the keyword consecutively, because obviously all words are contained in the alphabet. So first of all, the K1 alphabet is where the plaintext contains the keyword. So this is when you write out the ciphertext letter in alphabetical order, and then you write out each corresponding plaintext letter above the ciphertext, and then the plaintext letters will, the plaintext alphabet will form a keyword. So in this case, oops, in this case, your keyword is complex. And if you see here, you can see the word complex is literally in the mapping of the plaintext alphabet to ciphertext alphabet. So like here, it literally says complex. And you'll also notice that the ciphertext on the bottom is written in alphabetical order, and alphabetical order doesn't necessarily mean you have to start from A. So in this case, it starts from F, and then it proceeds all the way to Z, and then it goes back to A. Now, the reason here is actually you can't have the ciphertext start alphabetically with A, because then you will end up with a few letters of plaintext and ciphertext that map to themselves, and we can't have that. So, but you also will notice that in the plaintext, after you have the keyword, the alphabet also proceeds alphabetically, but without repetition. So because complex has a C in it, here this goes A, B, D instead of A, B, C, D because we can't have duplicates. And similarly with the K2 alphabet, it's like K1, but instead of the plaintext having the keyword, the ciphertext contains the keyword when the plaintext is written alphabetically. So once again, you don't want to start the plaintext, um, you don't want to start the plaintext on A when you're writing it alphabetically because otherwise it just doesn't work out. You're going to inevitably end up with duplicates. Now, you can kind of think of this as if you had the regular alphabets of like if you had them in regular alphabetical order and then you took the letters of the keyword and then you moved them to the start and you just shifted everything down accordingly. So that is the K1 and K2 alphabets. And okay, I don't know if I need to mention this, but of course you can use any type of any keyword you want as long as it's less than 26 letters, obviously, or it can be equal to 26 letters, but as long as the keyword itself doesn't have duplicate letters. So yeah, that's the K1, K2 alphabets. And do you guys have questions about that? Okay, no. In that case, I don't know if we. Okay, I do not believe we have time to look through practice problems. So, okay, in that case, I will talk about the practice problems next time at the beginning of class, and I'll send out the homework problems, which are, as usual, optional, but it's highly recommended. I think they're kind of fun. And In addition, if you find that you're extremely interested in decrypting aristocrats, you can search up, like, there are websites online where you can like play, well, not play, but it just automatically generates a bunch of encrypted quotes for you, and you can just decrypt them, and you can spend so many hours of your life on that. It's extremely worthwhile. So yeah, that's all for today, actually. It is 3 o'clock, so yeah, we'll keep talking about this a little bit more tomorrow, and then we'll move on. So yeah, that is it. Okay, goodbye.